This lecture is on conservation of energy. Our essential question is, how does energy move around in systems? The law of conservation of energy, which you may or may not have heard of before, is the one that states energy cannot be created or destroyed. It merely changes form. So in this lecture, we're going to explore what that means and how we can apply that to our understanding of the different energy types and how energy is moving around within systems of different objects. So, our first term is energy transfer. And all energy can be traced back to the Big Bang, talking about the origin of the universe. Energy has been transferring from one object to another ever since the beginning of the universe. So, um, let's say that you have a light on in your room. How does that move back to the Big Bang? Let's talk about it. So, you have a lamp on. We have light energy, L, from the lamp. And that came from an electrical socket, which came from water in a dam. We're talking hydroelectric energy, where that water is moving, kinetic energy moving within the dam to generate electricity, which came from water in the atmosphere, the rain that filled up that reservoir, which came from, oh, and that's gravitational energy as that water fell down, which came from a warm object that was evaporating. We have some thermal energy as that water is evaporating off of, in this case, a wet log, which came from sunlight, light energy, different kind of light energy, which came from nuclear reactions within the sun's core, which came from gases that were all gravitationally pulled together in space, which came from, you guessed it, the Big Bang, which was motion energy. So, if we follow any type of energy back far enough, we will always get back to the Big Bang. Now, let me see if I can find my writing tools. Excellent. Now, a couple of notes here that I want you to see and write in your notebook. Energy transfer, as you saw me do, is shown by a straight arrow. And it always goes from one object to another. Okay, so this is something that's happening when energy is moving from one place to another place. Okay, and I'm going to clear that. Let's compare that with energy transformation. Energy can also be transformed when from one type into another within a single object or a system of objects. So let's go ahead and annotate our notes here. I like to use for an energy transformation when I know that the energy is changing from one type to another. So one type of energy into another. I like to use this kind of loop-de-loop arrow for an energy transformation. Um, and this can happen within the object itself or in another one. So, the way that I imagine this is transformation is like a change. You got that in the energy skate park activity, like a caterpillar transforming into a butterfly. So here's an example. We have these skydivers, and this is gravitational energy transforming into kinetic energy as the person falls or as these people fall. That's within that single object. Here's another single object, or we could even think of this as a system of wire and light bulb and other wire. We have electrical energy that is transforming into light energy in the light bulb. And now, important to note, we also have some other types of energy that are generated as waste energy. I'll go ahead and get my pen out here. We talk about waste energy as the energy types that we don't necessarily want to get from the system, but are kind of always happening. So one of those ones that is often considered a waste energy is sound. Think about the buzzing sound in those light bulbs, or the whoosh of that of those skydivers falling as the air is kind of moving past them. And heat from friction is the other waste energy. Now, I don't know, it might be better here to be highlighting rather than circling. Um, and so that's thinking about the friction. This is going to be, both of these examples are kind of hard to tell, but the friction is those air molecules that are hitting the person and kind of, honestly, it's slowing them down, right? You don't just continue. You can feel that air that's hitting you. I don't want to get too deep into this. Or in the light bulb, you've got the filament right here is heating up, and that releases, that's part of what generates the light, but also this light bulb gets really hot and generates this thermal energy that's going off. Okay. To understand how energy is transferring and transforming within a system, it's helpful to make these energy bar charts. You got some of this practice with the energy skate park, and you're going to get a little bit more practice. So let's take Jack and Jill running up the hill. As they are running up, this system contains the chemical energy that's in their bodies, right? It takes our chemical energy, our effort to get ourselves up the hill. Um, so once they get to that top of the hill, then they have this gravitational energy because you know what's about to happen. They're going to fall down the hill, and that's due to gravity. Um, they also had some waste energy in terms of the sound. Remember, W stands for wave, which sound is a type of wave. So waste energy as they're clomping up the hill and breathing heavy, and thermal energy as they are sweating. Those are the waste energies that are being released. And then they fall down the hill. That system contains, as they're falling, think about what that's going to be. That's right, that kinetic energy, that mechanical movement energy. And naturally, as well, a lot of sound as they are hitting things, and thermal energy, which isn't going to be as much, right? There was lots of thermal energy as they're going up the hill. That thermal energy is going to be a lot less as they are, they're not heating up as much. But every time they hit something, they're warming it up just a little bit. So we want to make this into energy bar charts. Here's what this would look like. All right, so we have our key right here, and what you should do is take either some colored pencils, or you're going to want to mark the type of energy on your bar chart itself. So let me show you what this looks like. At the beginning of the climb, we have EC, right? That's chemical energy. And notice that we can actually put numbers to it, right? 10,000 joules of chemical energy. That consists of the total amount of energy in the system. That's sigma E. If you remember from our first unit, sigma E is like that sum of all of the energy types, right? That term, this kind of sideways M is called sigma. It's basically adding all of those together. So at the beginning of the climb, all of the energy within this system is the chemical energy. When they get to the top of the hill, we have our gravitational potential energy, and there has been some waste energy in sound and thermal. And then as they tumble down, we have that kinetic mechanical motion energy, as well as still they're on their way down. They haven't gotten down to the bottom. So we have potential and gravitational energy, and we have a lot of that waste energy as well. Because, eventually once they get to the bottom, they're not just going to continue rolling on forever. All of this movement energy will be transformed into the um, uh, waste energy. So as I'm writing this, right, all of this is happening within these two people. So there's no transfers happening in this particular scenario. All of this is a transformation, excuse me, with that little arrow. Then we had this one transform into these two, right? Or you could even show this as, so that's kind of, yeah, I guess that's the way that I might draw these transformations that are happening. This is transforming into um, the waste energy. Okay. All right. Okay. So, yeah, just want to make sure we're clear with that. It's the movement energy that transformed into the waste energy. It's the chemical energy that transformed into the waste energy. It's not the potential energy that transformed into waste energy. It was the chemical energy or the movement. So gravity itself isn't becoming sound or thermal energy. Got a little bit sloppy. Hopefully you followed my train of thought there. Okay, so in summary, in review, the law of conservation of energy states that energy cannot be created or destroyed. So here's what you will need to do for the mastery check and what I want you to understand from this lecture. Um, Explain what that law means and why it is true. Identify the energy types present in different systems. Use the terms transfer and transform appropriately to describe energy movement and change in a system. And some examples that I would give you for some systems that you can kind of think about as you're doing this review. Maybe you talk this through with a partner. Biking down a hill, bungee jumping, eating food. You can come up with your own. But those are some example systems. All right, so I want you to revisit the essential question: how does energy move around in systems? And in your response in your notes, be sure to use the words transfer and transform and provide an example.